So we were discussing about work. What is work? Work is the product of force and displacement, force component in the direction of the force and displacement. Okay. So W equal to F cos theta into D, which is also known as F into D cos theta. Now there are three cases in that. What are they? W equal theta equal to 0 degrees. If theta equal to 0, cos 90 is how much? If theta equal to 0, cos 90 is how much? Sorry, cos 0. If theta equal to 0, cos 0 is 1. So work done will be F into D. If theta equal to 180 degrees. If theta equal to 180 degrees, cos 180 is minus 1.
Minus.
So W equal to minus F dot D. So if theta equal to 0, the work done is known as positive or negative?
Positive.
Positive work done. If theta equal to 180 degrees, work done is
Negative.
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 And now zero work done. Zero work done means either if W equal to, if force or displacement, both any one of them is equal to 0, then the work done is equal to 0. Or if theta equal to how much?
90 degrees.
90 degrees. If theta equal to 90 degrees, in that case also cos 90 will become 0. So work done equal to 0. So I have given certain examples yesterday. So a weightlifter holding a weighing bar or weight bar on his shoulder. So displacement is 0. One more case, a potter carrying luggage on his head. So what happens? The angle between the weight and the displacement is 90 degrees. So according to physics, he is not doing any work. And rotation of the moon around the earth, rotation of the earth around the sun. These are the examples of zero work done. Okay. Now in work energy theorem, according to work energy theorem, what he says? So the change in kinetic energy equal to work done. Kf minus Ki. Kf means final kinetic energy. Ki means initial kinetic energy. Kf minus Ki is equal to work done. Next case. Next one. So we had work done by variable force, right? And dot product also. I dot I equal to J dot J equal to K dot K is how much? I dot I equal to J dot J is 1.
1.
Why? Because angle between the same vector is 0 and cos 0 will become 1. Now I dot J equal to J dot K equal to K dot I is equal to how much?
0.
0.
Very good. Now work done by variable force. Why variable force? Maybe if the force is not constant. There are many situations where force is not constant. In that situation, what are we writing? W equal to summation xi to xl fx into dx. So instead of writing that, we convert it into integration. W equal to what? Integration fx dx. Okay. Integration means for the whole value. Okay. We have differentiation, integration in calculus. I think that these are already told in the class also. In calculus, we have differentiation and integration. Differentiation, if you want to find out the slope, we say differentiation. If you want to find out the area under the curve, then we say integration. Understood? Area under the curve is integration. So these are the two cases. That is integration and differentiation. So, so the concept of potential energy, that also we have seen yesterday. Law of conservation of energy. So what is law of conservation of energy? Energy is neither created nor destroyed, but can be transformed from one form to another form. After that, so we did one derivation on this conservation of mechanical energy at point A. That means when the body is falling towards the surface of the ground. There are 3 points A, B, C. At A, only there is gravitational potential energy. At B, there are two energies, potential and kinetic at the same time. At C, there is only kinetic energy at one time. Okay, at this point, only kinetic energy, only potential energy, kinetic and potential. So we have written all these, we have calculated all the values. Now we have in conservation of mechanical energy. So before that, we had mechanical energies classified into two, potential and kinetic. What is potential energy?
Energy possessed by a body due to its height.
Very good. Energy possessed by the body due to the position or due to the shape. If it is due to the position, what is that called? That is known as gravitational potential energy. If it is due to the shape, it is known as
Elastic.
Elastic potential energy.
the formula for gravitational potential energy is what?
FG.
mgh. The formula for gravitational potential energy is mgh, and the formula for elastic potential energy is half kx square, where k is known as spring constant and x is known as displacement. Okay, now next is kinetic energy. What is kinetic energy? Energy possessed by the body due to the motion. Energy possessed by the body due to the motion is known as kinetic energy. Okay, so last part is conservation of mechanical energy. We have seen this one. Now, today we will discuss spring potential energy of a spring. And next one is forms of energy, different forms of energy. What are the different forms of energy? Then power, then collisions. Last part will be the collisions. We'll try to see how much we can complete today. Okay, so there are two derivations which we are going to do now today in today's lesson. And the remaining will be definitions and normal definitions. Clear? So we'll start now. I think ma'am wrote a message in the group, right? For those who did not take the certificates, please, you have to collect the certificates today from the school. Okay. Now, so here, the next concept is about the potential energy of a spring. Okay. Potential energy of the spring. So potential energy of a spring. Okay. Potential energy of a spring. Now, see here. So before going to that, we have Hooke's law. Hooke's law. The Hooke's law says Robert Hooke. Okay. Robert Hooke, based on his, he has given the law, that is Hooke's law. According, that is under elastic limit. Again, we will discuss this in chapter number 8. I think. Yeah, mechanical properties of solid state. Under elastic limit. Under elastic limit, stress is proportional to strain. Stress is proportional to strain. Or we have one more definition. Under elastic limit. Under elastic limit, force is proportional to extension. Force is proportional to extension. Under elastic limit, force is proportional to extension. According to that, he says that suppose there is a spring mass system like this. So this is a spring mass system. So what happens when you stretch the spring and leave it? The force and the displacement. If this is the force, this is the displacement. Both are in opposite direction. So F is proportional to minus x. To remove the proportionality constant, we are writing minus kx. Okay, where k is said to be what? Spring constant. Where k is said to be spring constant. So it is measured in what? Measured in Newton per meter. What is a spring constant? Spring constant is the stiffness of the spring. The stiffness or hardness of the spring. Stiffness or hardness of the spring is known as spring constant. Okay. Stiffness or hardness of the spring is known as spring constant. Now, so how do we calculate the spring constant? See, what do we do? This is the experiment which you have done in your lab also. Okay. So we have done in the lab also, like there is a spring here. Remember this one? A helical spring was there. Did you do this experiment? Yes. Did you do this experiment? Helical spring experiment? Yes or no?
Yes, sir.
Yes.
So what happens? The spring. So when you put the mass, then there is elongation, right? There is elongation. There is elongation in the spring. So L is the elongation of the spring. So F is equal to what? F equal to mg. This is equation number 1. F is equal to kx minus kx or ks. Okay. Equation number 2. So the x is what? Displacement. When you put mass, there is some displacement. Then equate both of them. Mg is equal to, this is the way we to calculate the spring constant. Every spring is not the same. Every spring is not the same. Just there are different types of spring. A spring which is there in the pen is very soft. A spring which is in the two-wheeler. A spring which is in the four-wheeler. In the truck. Okay, in the cranes. Everywhere we have springs. But the spring constant value is different from one to another. Okay, it's not the same. So if is equal to mg. So mg is equal to kx, k equal to what? Mg by x. This is the way we calculate the spring constant. M is the mass connected to the spring, G is the gravity, X is the extension. Sometimes the extension is given in centimeters and mass is given in grams. In that case, what will be G? X is in centimeters, mass is in grams. What will be G value? What will be G value? Don't sleep in the class, please. Today's topic is important. Now, so G is what? Should we take 9.8 meter per second square? Should we take 9.8 meter per second square? So if M is in grams, M is taken in grams, X is in centimeters, then gravity should be taken in 980 centimeters per second square. Keep this in the mind. While doing the experiment also, you need to substitute 980, not 9.8. When the things are taken in grams and centimeters. Please note down this one, then we'll go ahead with the case. Okay.
Sir, can you read?
Now here we have, as we know that, see, this is the spring. This is the normal position of the spring. Normal position of the spring. This when we stretch it. This when we stretch the spring. This when we stretches the spring, then so this is the main position. Okay, this is the main position, and these two are the extreme positions. Here, x is equal to 0. Now what happens? If fs equal to 0, x equal to 0. Next is what? F is negative. In this case, F is negative and x is positive. See, displacement is positive and force is negative. In this case, Fs is positive and x is negative. Understood? See, there are 3 cases. Normal situation, when it is stretched. Okay. So when it is, this is when the normal situation, this is when the spring is stretched, this is when the string is compressed. Means if you stretch the spring and release it, it starts vibrating, is it not? The spring starts vibrating towards its mean position. Now what happens is, when the spring is stretched, force is negative, but x is positive. So, and the second one is when the spring is compressed, force is positive, but x is negative. Compression, we are taking extension as positive. Extension as taken as positive and compression is taken as negative. Okay, compression is taken as negative. Now, F equal to, I will take F only. Now, Fs means force of the spring. Should I take only F here instead of taking Fs and all? So F equal to minus Kx. Okay. So if I want to find out the work done by variable force, what is the formula? Work done by variable force formula is, see, once again here, F is proportional to minus X, F is equal to minus Kx. So where K is spring constant, what are the units? It is measured in Newton per meter, dyne per centimeter. Okay. And what is the dimensional formula? Can anyone say? So Newton means ml t to the power of minus 2, right? Divided by m. Is it not? So that will become ml meter, right? Meter means L. M t to the power of minus 2. This is a dimensional formula. Clear? Dimensional formula. Now next, work done by variable force is what? W equal to. So 0 to xm. What is xm? Fx dx. That is a function of x dx. What is xm? Xm is maximum 0. So that means what? Initial point. Initial point is mean position. That is 0. Okay, that is mean position. And final position is what? Final point. Suppose if you are taking xm, that is what? Extreme position. That is said to be extreme position, Fx dx. But what is Fx? W equal to integration of Kx. I'm taking minus here outside dx, 0 to xm. Now I'm taking, see, work done by variable force formula is integration of Fx dx. Initial point to final point. From where to where? From 0 to extreme position. This is the extreme position. These two are the extreme positions. This is the mean position. Mean, extreme position. See, I wrote already here. Mean, extreme, and extreme. Yeah, I already wrote here. So 0 to xm, only to extreme. Now I'm taking k outside. So it is equal to minus k outside. Integration of 0 to xm into x dx. What is the integration of x? X is x square by 2. From where to where? 0 to xm. Now, so that will become W equal to what? Minus k into xm square by 2 minus 0. Xm, wherever there is x, you write xm. So xm square. So xm square, it will become xm square by 2. So that will become what? W equal to minus k into xm square by 2. Minus k into xm square by 2. If force is positive, here in this case, what is that? Force is the work done by the force, pulling force is positive. So therefore, when I am applying the force is positive, then it will become positive. So W equal to, it will become half k xm square. If the force is positive, work done is positive. Is it clear? Once again from the beginning, this is a spring which is in the spring mass system. A spring is connected with the mass. This is the initial, this is the mean position. You stretch it and release it. It starts oscillating towards its mean position. So if F is negative, X is positive. If F is positive, X is negative. So extension is positive and compression is negative. So here we write F is proportional to minus X, F equal to minus Kx. K is spring constant, which is measured in Newton per meter or dyne per centimeter. So W equal to what? 0 to xm Fx dx. So initial point is 0 and final point is xm. So W equal to minus integration 0 to xm Kx dx. K minus K you take outside x dx. So minus K, x integration is x square by 2, 0 to xm. So substitute the values xm square by 2 minus K into xm square by 2 or a half Kx square. Okay. So that is the first part of the derivation. There are three parts for the derivation. First part is only from mean to extreme. Second part is extreme to extreme. Third part is one cycle. Means it goes from one cycle means from mean position to extreme position, extreme to extreme position, then coming back to the mean position. So these are the three cases. So first case we have done now. So please copy this. If you have any doubt, please ask.
So in the last we got W equal to minus. Where is the then when you finally wrote the minus?
Here it is minus kx square, right?
Yes.
Yeah. So I wrote if f is positive. Okay. So f is, since it overcomes the spring force, if f is positive, then only we can write half kx square. Clear? Work done is a scalar
Okay.
quantity, it's not a vector quantity. Got it?
Okay. Okay. Yes.
Okay. Please copy if you have any doubt, please ask. Now the second part. So we have xi to xf. Maybe. Now it is a general one. Second one. So the first one was from mean to extreme. The second one can be taken from extreme to extreme, can be taken to mean to extreme anyway. So we are writing W equal to what? W equal to integration of xi to xf. Xi to xf, fx dx. So W equal to what? Fx equal to what? Minus kx. Minus, I'll write minus k outside. Okay, minus k integration x dx xi to xf. So this will become W equal to minus k. Integration of x is what? X square by 2. X square by 2 x